Okay, we are going to solve an array of zeros, ones, and twos. Needs to be sorted in an efficient way. It's also known as a Dutch national flag problem. And to get started, let's just make a little sample of an array. Okay. All right, here's an array of zeros, ones, and twos. And what we're basically going to do is we're going to have a start, an end, and kind of like a midpoint. I'm going to go ahead and start it at the first element because we're going to put a test in that if the array is 0 or if the array is null, we'll throw an exception. And if the array only has one element, we'll just return that array as is because there's no sorting to be done. So when we get into our loop, we'll already have m starting at 1 and the others starting at their proper positions. Let's go ahead and make a little chart to kind of just go through M and E. And basically, while M does not equal or is not greater than E, we're going to keep looping through. So once those two hit, we know we've gone through the entire array. And each time we go through, we're going to look at M. And if M is, we look at M and E, and if M is greater than E, then we need to swap them. So let's go ahead and swap those. And now M is 0 and E is 1. And so far, hold on, let me write down our beginning numbers here. E is 6. Okay. Then we go through and look at M and S. Is M less than S? No, it's not. They're the same, so we don't need to do anything. And then we go and we look at if S is at 0, we need to increase S by 1. So now S is pointing here and it's now 1. And then we look at E. If E is a 2, then we would decrement E, but it's not. So we were going to just keep it at 6. And then we look at M, and if M equals 1, then we would want to increase it, but it doesn't. However, M does equal S, and we don't want that. So we're going to go ahead and increase M to the next spot. Okay, so now M is at 2, and S is 1. Okay, and we go through again, and we say, okay, is M greater than E, which it is? So we're going to go ahead and do a swap. Okay, and if we look at M is 1 less than 0, it's not, so we keep it here. Then we go through and we look at is S equal to 0, which it is. So we need to increase it. And then we also look at E is equal to 2, which it is. So we need to decrement it. Okay, and then we look at M, is M equal to 1? It is. So we want to go ahead and increase that. Okay, so now M is at 3, E is at 5, and S is at 2. All right, and then we go again and we look at M, it's 0. Is 0 greater than the 2 that E's at? No, it's not. Is 0 less than 1? Yes, it is. So we want to swap them. M is now 1, S is at 0. And then we go and we say, is S at 0? Which it is. So we want to move it to here. And we look at M and we look at E and it's at 2. So we want to decrement that as well. So now E is at 4, S is at 3, and then we look at M, it's at a 1. So we go ahead and increase that. And now we're looking at is S equal to or greater than M? It's not, so we don't need to do anything else. Then we're going to go back in our loop and we're going to see that M and E are equal. So then we're not going to loop through anymore and we've completed. So let's go ahead and write this in code. Okay. All right, well, we know we're going to need two functions. We're going to do a swap. So let's go ahead and put that here. Public int, it's going to return an array. Swap, it's going to take in an array. Oops, let's write that a little better. Okay. It's going to take in an int A and int B. Okay. And in there, all we do is there's a temp. And it's going to first be set to array at B. Then array at B is going to equal array at A. And then array at A equals our temp. Okay, and we're just going to return the array. Basic swap function. All right, and then we know we need to go in and write our main function. We'll say, we'll call it the Dutch flag. And it's going to take in an array of integers. Okay, we're going to do some basic tests first. If the array is equal to 0, then we want to throw an exception, something like the array doesn't exist. There'll be some sort of message here. Okay. Else, if the array dot length is equal to 1, then we know we want to return the array as is. Else, we're going to go in and do what we need to do. So we're going to need to first declare some variables. So we have int s for the start, and that's going to equal 0. We have int m, and that's going to be 1. And we have int e, and that's going to be array.length plus 1, so that it's at, oh no, sorry, minus 1, not plus 1. All right, length minus 1. All right, and then we're just going to go into our while loop. Okay, while m doesn't equal e, so while m is less than e, we're going to say, first we want to check and see, is m, if array at m is greater than array at e, then we want to swap. We'll send it the array, we'll send it m, and we'll send e. Okay, and then we say if array at m is less than array at S, then we want to swap array M and S. Okay, we'll just kind of go to this other side here. And then we just need to set up our conditions now to make sure that we are incrementing and decrementing the correct indices. So if S equals 0, then we know we need to do an S++. If E equals, oh, sorry, that is not going to work. If array at S is equal to 0, that makes more sense. And if array at E is equal to 2, we want to do an E minus minus. And then we know if M is equal to 1, we want to do an M++. And if M is less than or equal to S, we want to do an M++. This just kind of keeps us from getting stuck in with having all ones in the middle or something. We need to keep M moving along. All right, so that should do it. Then we return our array and end the program. Okay. All right, let's go ahead and do a test. Okay, we'll get some new numbers in there just to make sure it's working. Okay, I'll put a 1, 2, 0, 0, 1, 2, and 0. Okay, so we're going to start, and S is starting at, well, first we're going to look, and array.length does not equal 0, so we're not going to throw that exception. Else if array.length equals 1, which it doesn't. So we're going to go into our algorithm, and S equals 0, M equals 1, and E is array.length minus 1. So E is 0, 1, 2, 3, 4, 5, 6. Okay, so we can go ahead and look at this. If array at M, which is here, which is 2, there's we can label these S and E. So if array at M, which is 2, is greater than array at E, which it is, then we're going to swap. So we go in and we swap them here in our swap function. And now 2 is here and 0 is here. Okay, and then we go in, if array at M is less than array at S, which it is, we're going to do the swap again. So we can swap, and this is now 0, and this is now 1. Okay, if an array at S equals 0, we need to do an S++. So now here's S. S is 1. If array at E equals 2, which it does, we need to do an E minus minus. So now E goes here. E is now 5. And then if M equals 1, M++. So we can just do this. And now M is equal to 2. Okay, and here we go into our loop. Well, m is less than e, which 2 is less than 5. So we come in and we say if array at m is greater than array at e, it's not. If array at m is less than array at s, which it is, then we're going to swap. Okay, this is now 0, this is now 1. And then we come in here, if array at s equals 0, s plus plus. Okay. So now s is 2. If array at e equals 2, which it does, we're going to decrease it. Okay, so now e is 4. And if m equals 1, we increase it. Okay, and now m is 3. Okay, and then we look here at, and m is not less than or equal to s. So then we come in and we go back to our beginning of the while loop. M is less than E, 3 is less than 4, so we'll keep going. If array at M is greater than E, which 0 is not greater than 1, so we don't do that. If array at M is less than array at S, which it is, we're going to swap. And this is a 1. This is now 0. And we come in here. If array at S equals 0, we're going to increment. Now s equals 3. If array at e equals 2, it doesn't. If m equals 1, then m plus plus. So we just erase that. And now, okay, so e stayed at 4. Now m increased to 4. And then if we go back through, because we've met all those criteria, if we go back through, then m is less than e. Let's see, 4 is not less than 4. So we get out of the while loop and then we return our new array of zeros, ones, and twos. This is a big O of n complexity because it is a linear, it's a linear, basically a sort, but it just goes through the array n times at worst case.